All right, so here we are in 11.4 on fundamentals of probability. So what we're going to learn in this section is how to compute theoretical probability and how to compute empirical probability. So we can find probability by dividing one number by another. So probabilities are assigned to an event. Now, events are certain to occur, assigned probabilities of one. So if it's absolutely going to occur, it's a probability of one. So for the example, probability you're going to die is going to be a one. Now, in contrast, if an event cannot occur, its probability is zero. Now, the probability that Elvis will return and serenade us with one final reprise of Don't Be Cruel is zero. Now, the probabilities of events are expressed as numbers ranging from 0 to 1. And notice they're numbers from 0 to 1. So that means, 0, 0 0.1, 0.2, 0.45, all the way up to 1. These are not percentages or nothing else. They're probabilities. So they're a number, and it's usually a decimal somewhere between 0 and 1. Now, the closer you are to 1, the more likely the event's occurring, and the closer it is to 0, the less likely that event is going to occur. So theoretical probability. So here, for example, say you toss a coin. Now, although it's equally likely to land either heads up, which is going to be denoted in H for heads, or tails up, denoted by a T, the actual outcome is uncertain. So any occurrence for which the outcome is uncertain is called an experiment. So that's a word that we need to know about. Thus, tossing a coin is an example of an experiment. And a set of all possible outcomes of an experiment is called the sample space, another good word to learn. And that's the sample space of that experiment. And it's usually denoted as S, whereas experiment is usually denoted as E because you're going to do some event that's in that experiment. Now, the sample space for the coin tossing experiment is the sample space is equal to, now we're using braces here to represent what's inside of the sample space, and we either have a H or a T. Now, the event, which is denoted E from that subset of the sample space, is the subset E, and it can be, tails, or it could be heads, or whatever is landed when you flip that coin. Now, to calculate the theoretical probability of an event, we divide the number of outcomes resulting in the event by the total number of outcomes in the sample space. And the sum of the theoretical probabilities of all of the possible outcomes of a sample space had better come out to be equal to 1. So if we had an event was a tail and event was a heads, well, if we take 1 divided by 2, that's half. Heads is 1 divided by 2 is a half. Half plus a half is equal to 1. Okay, so that's kind of what we mean by all the sample space has to add to 1. All right, so computing theoretical probability. So if event E has N of E, and N of E here is the number of in that event, equally likely outcomes, and its sample space S has N of S, which is the number in the sample space S, equally likely outcomes. The theoretical probability of event E is denoted by P of E, and that's the number of outcomes of event E, of the N of E, divided by the total number of possible outcomes, the N of S. And how we use this formula to compute the probability of a coin landing tails up? Well, again, now we have E as tails. So the number of E in this case is going to be 1. And here N of S, well, there's 2 in the sample space here, so that's 2. So the probability of a coin landing tails up is going to be the number in E, 1, divided by the number in S, 2. So that's our 1/2. And again, if we had a different sample event and we had that was heads, it's going to have 1 over 2 as well. And then if we add those two together, we're going to get the total of 1, like we mentioned before. All right, so let's do a checkpoint. So we have a die and it's rolled once, and we're using a 6-sided die here. So that's going to be kind of a key to think about. What is the probability of rolling a 2? Okay, well, our event is going to be what? Well, we're going to roll a 2. The sample space is going to be what? Well, that's going to be the we roll 1, a 2, a 3, a 4, a 5, or a 6. Okay, so the number in E, so the probability of E is going to be the number in E, which is 1, over the number in S, which is 6. So our probability is going to be 1/6. And we usually leave it as a fraction if we get a fraction in it, because that's the actual exact number. If we make that out as a decimal, then it's not going to be as exact. So it's better to kind of leave it as fractions. B, the number less than 4. Okay, well, here our number less than 4. So we're going to have a 1, a 2, or a 3. And our sample space is the same, it's 6. So probability of E is going to be what? Well, it's going to be 3/6, which is 1/2. All right, so C, a number greater than 7. Okay, well, for C, the event is going to be what? Well, there's nothing. There's no number going to be greater than 7 in something between 1 and 6. So that means the probability of E is going to be 0/6, which is 0. And then a number less than 7. Okay, well, then here our event is going to be 1, 2, 3, 4, 5, or 6. And so the number there is going to be 6. So the probability of that event is going to be 6/6, which is 1. Okay. So that's how we kind of use, in this case, a die. We have to know our sample space, and then we can look at all the different kind of other events from that sample space. All right, so let's stop there and we'll come back for more.